Okay. Now recording.
Yes, sir.
Okay. So the same problem I put it over here in different programs, so it is easy to solve. You see, this is outer cylinder, and the red one is the shaft. Is rotating with certain RPM. Yeah, I put N1. Okay. So in outer cylinder or tube, it has radius RC, and the radius of the shaft is RS, and is rotating with RPM N1. Okay. So red one is shaft, outer one is the tube. The gap between these two actually is this much only. So we can figure. Okay. So let's now look the problem again. It's a cylindrical shaft diameter 95 millimeter. So I can say diameter of the given. Every problem at first you write down what data is given. Okay. You read the question, problem question. Then you need to realize that is related to which formula. You have to realize immediately in your brain that I need to use this formula. Okay. Then you figure out what data is given. You write down step by step. So read first line. So there is a number 95. That means one data is there. So what is that data? Diameter of the shaft. So I write down diameter of the shaft, D subscript equal to 95 millimeter. This shaft is rotating at the speed of 50 RPM. So rotational speed of the shaft N1 is given 50 RPM. You can use any uh, subscription of only N you can use, and is rotated inside a cylinder of 96.4 millimeter diameter. So I write down diameter of the cylinder DC equal to 96.4 millimeter, and it's saying both shaft and the cylinder 50 millimeter long. So you have to put that length of the shaft and cylinder L equal to 50.5 meter, not 50. Then torque required to rotate the shaft, torque equal to 1 Newton meter. So I put required torque to drive the shaft T equal to 1 Newton meter. Now you can figure out the radius of both uh, shaft and the tube. Then you can figure out the y. So radius of the shaft RS equal to ds by 2. I get the number over here. Okay. Then the radius of the cylinder RC equal to DC divided by 2. So I got it over here. So this much data is given. Now what need to figure out? You need to figure out the viscosity of the oil between the cylinder and the shaft. So we say viscosity mu equal to what? Now, which formula I need to apply? Obviously, you need to apply the Newton law of viscosity. Let me bring this figure at the bottom. Okay. So what is our equation? This one, tau equal to mu du by dy, and du by dy equal to, you can write down this one, or we know tau equal to f by a. So right over here, instead of tau, we put f by a, and right over here like that. But what you need to figure out? You need to figure out the mu. So mu equal to f by a into y by u. Now you see, easily you can figure out this y. What is the y? The gap between these two cylinders, that is the y. What is the u? Linear velocity of this plate, not plate, this shaft. So in the shaft, it's a rotating. So you get a rotational speed omega. Omega multiplied by radius, you'll get the u. So these two data we are getting. Now, how will get the area? Area easily can figure out, because this is a shaft, right? So if this is the long shaft, if I see side view, this will be length L. And what will be this distance? Width. Width will be, if I, this width will be 2 pi r, right? I can say this will be 2 pi into r, right? And what will be the outer surface length? Length is given L equal to 50 meter, point, I'm sorry, zero point 0.5. So I can say this one is zero point 0.5 meter. So obviously you are getting the area. Now, how will get the F? It's a torque is 1 Newton meter. So we know that torque T equal to F, that means force into distance. What is the distance out here? Is R. If I think that this is the diameter of the shaft, this is the shaft, and its force, every point force working tangent to the surface of the shaft is F. So how will be torque? Torque will be center distance into F. So torque T equal to F into R. So torque is given, radius given, we can figure out the F from here. Okay. So let's see how we solve it. You see, we figure out angular velocity is given, RPM is given, then omega equal to pi n divided by 60. What is the unit? Radian per second. So this is my omega. Now u, that means linear velocity, equal to omega into r. So you get the u. So in your formula, this u is calculated. Now you need to figure out the torque. So torque T equal to F into RS, radius of the shaft. And radius of the shaft is already given, we figure out. Torque is given. So we can say F equal to T by RS. So you see our torque is radius RS and torque is given. So from here, we can figure out the force. And we are getting the force 21, about 21 Newton. Now, y, what will be the y? Distance between two shaft, RC minus RS. So we get the y. And what is the area of the this shaft? Area mean peripheral area, because peripheral area is moving. Um, explain it again you that this one is rotating. That means this peripheral area is moving over the fixed plate. What is the fixed plate? My tube. So this area, whole surface area, will be length into the width. What is the width? 2 pi r. So we are getting the area AS equal to pi r into L. So AS equal to this mass. Now you just put in the equation. This is our equation. And immediately giving my this one, kg meter per second. But what is our unit actually? Our unit actually this one, Newton second meter square. But this program is giving like kg meter, kg by meter second. And this is the same. I show the over here. The Newton, you can say kg meter per second square. Then you put this second over here. Then you simplify, you'll get the same thing. So kg meter second equal to Newton second meter square. So this is the result. Okay. And I use this program is called MathCat. It's very easier to solve. It's giving result automatically. Say for example, you see right over here, what is the result of 0.4, about 0.439, right? So if I change the value of torque, is a torque, instead of 1, I am putting 5 kilonewton. then you will see the result will be automatically updated. Instead of zero point 0.4 is coming or about 2. So what is the application of this software? Say you are working in a company, they make journal bearing, okay? And you join in that company and your boss give you a special assignment. Okay, I'm going for holiday for 2 weeks and here is the data, you design the shaft. Okay, so design the shaft, everything. Then after he come back, he say, hey, did you make the design? You say, yes, sir, I did. Well, change the length, change the diameter. Then what will do? You need to again do everything from the beginning. So instead of doing that, if you use this kind of software, you just change the data. You see, I change the length instead of 0.5, say I'm saying length is 2.5. So I change the torque. Instead of torque, I'm keeping back to 1. And you see my result will be automatically right over now 0.08, automatically sense updating. Okay, this is the beauty of this software. This is called MathCAD software. Also, you can solve equation. So, any question from this problem? Anyone? Any question? Hello? No? No question?
Sir.
Okay. So let's see what we have in the next slide. So we found a law, right? Newton law of viscosity. So we found Newton law of viscosity when a fluid follow that law, that is called Newtonian fluid. It's a
স্যার
fluid,
আসসালামু আলাইকুম স্যার
what to say?
স্যার আমাদের 10:30 থেকে ল্যাব ছিল স্যার
Okay, already time. Okay, we just finish this slide, not that much. Okay, so a fluid obeying Newton law of viscosity is called Newtonian fluid, and if a fluid does not follow or maintain the Newton law of viscosity, they are called non-Newtonian fluid. And what is the Newtonian fluid? Water, air, glycerin, they are called Newtonian fluid. And non-Newtonian fluid, like you have ketchup, paint, then you use gel in the hair, that is called styling gel. Then they have other fluid, it's called dilatant fluid. They don't obey the Newton law of viscosity. So just remember there are two types of fluid. One is called Newtonian fluid, other is called non-Newtonian fluid. If it follow the Newton law of viscosity, then call it Newtonian. If it does not follow the law of Newton law of viscosity, then it is called non-Newtonian fluid. What is the example of non-Newtonian fluid? Paint, ketchup, styling gel, and also some fluid that we use in the automobile gear. Okay, that is called dilatant fluid. And example of Newtonian fluid: oil, water, then glycerin, air. That is example of Newtonian fluid. Okay, so we stop over here.